WireGuard is a popular VPN protocol. It is built inside the Linux kernel, which makes it supported by default on almost every Linux distribution. WireGuard was built on the principle of zero trust, which means that a successful WireGuard connection does not allow anything, and all access must be granted explicitly. This makes WireGuard hard to configure manually. We will change that today. We will use Ansible to configure WireGuard in our Devlab router in a repeatable and reproducible way. But first, what do we want to do with WireGuard? WireGuard can be set up in multiple modes. In our context, we want hosts from outside the Devlab network to connect to hosts inside the Devlab network. Some hosts might require only limited access. For example, like for testing a system or for viewing a web server. Other remote hosts might require advanced access to some specific Devlab hosts. And some administrators might require unrestricted access to all the hosts in the Devlab network. If you have been following the series, you see that when I want to access something inside the Devlab network, I always use a Fedora virtual machine that is inside my main lab and connected to both the Devlab network and the main network. Let's say I want to access this host here from my main network, from this machine, the machine that I am using to record this. Normally, I would not be able to do that because this is behind a NAT box. Everything here is behind a NAT box that is a network address translation box that prevents access from the outside. So what we want to do now is to allow access to some of these hosts, for example, to the Drupal dev, which runs a copy of Drupal and a copy of Laravel Lumen, and to WordPress, this WordPress site that runs a copy of WordPress. Let's say I want somebody to have a look at them and test them and give me some input, or maybe I want to do quality assurance, or I have reasons to open my Devlab to the outside. Some other hosts might require, for example, connecting to the GitLab and possibly running commands on our Swarm network. Some other hosts might be interested in managing the entire Devlab. For example, I want to configure this machine here to access all the Devlab so that I don't need to use this virtual machine here. So that is what we want to do now. And to do that, we need to model our hosts. The model I came up with is to model them as services. So we will have a service that is, for example, this Drupal development and this WordPress development. And we want to allow some hosts from the outside to access this service. We will have another service that is the administration of the entire Devlab. And we can come up with services, for example, for accessing the certificate authority, for if we want to allow a host to sign certificates using our certificate authority. We can design our services depending on what we need here. What I will show you is just an example for this development laboratory that we have built in this series. Now let's see the end result. I am now in my virtual machine, in this virtual machine here. If I go outside it, now I am on my own desktop that does not have access to the Devlab network. Remember that the Devlab network is entirely hosted by Proxmox. It does not have an outside connection other than the router. So here I have access to GitLab, and this is gitlab.devlab, the GitLab instance that I installed inside the Devlab. And if you see here, I also have access to drupal-dev.devlab :81, which is my Drupal instance that is running inside the Devlab. Now I want to show you if I want to disconnect this connection. So I have a connection here that is connected to WireGuard. If I want to disconnect this connection and connect a different WireGuard connection, which is WireGuard test. So I want to disconnect WireGuard and connect WireGuard test. If I refresh this page here, it's working. I can view another article and another article. However, if I refresh this page here, it times out because the connections are being dropped. So I have set up secure access to some of my hosts and administrator access to different hosts. based on the VPN connections. Let's look at the VPN connections. First, let me disconnect this connection and connect WireGuard again and refresh this page. So now I get a result from GitLab. And this connection is still active. So let's see the connections that we have here. I have defined a private key in the connection, nothing here. And in the IB, I gave myself an IB 10.10.15.3. We will see these IBs when we discuss the WireGuard network. I am using the DNS server of the Devlab so that I can get these this domain, the Devlab. And in peers here, I have the public key of the WireGuard server, which is my router. I define that I want to access the entire Devlab network. This is, I want to grant myself access to the entire Devlab network and to the router, which is 10.10.15.1. And the endpoint address is an address that I can access on my local network. This should be publicly accessible or available to the host that will connect. And in that case, I'm using the IB of the Devlab router in my main network. And this is the port that default port for WireGuard. Now, the other connection is very similar to this, with the difference that we have like the setup here is different in the IBs. This is a different IB. I have 10.10.10.10 here. And peers, in the peers here, I have the network, the 10.10 network, and 10.10.10.1. This one. And the Devlab network. The other settings are the same, and this is how I set up the network, and this is how I can give restricted access to some ports in the Devlab network and administrator access to the entire Devlab network. Now let's see how I made that. This is a small diagram that represents what we have just seen. So I have a tester here that has a specific IP address on the WireGuard network. The WireGuard server for this tester has this IP. So notice here that I'm using 10.10, then I'm changing the last 2 octets. So basically I'm using a class B network for my WireGuard network. And I'm changing these IPs here, these numbers here. And for each collection of hosts, I am giving a class C network. So I have a class C network, .15 for the testers, and I have a class C network also for the administration. And this can include administration devices. I have like multiple devices that I might need to connect to the Devlab using. On the other side, we have the services, and you see we have a service that we defined here. It has the IPs, and on each IP we have specific ports that we need to access. And we have other services that are not part of this service. We will create them as part of the admin service that includes everything here. Of course, I can create multiple services here, and I can create multiple user groups here, and I can create rules to connect each user group to the services that they are allowed to connect to. And this is the basic concept of zero trust. Nobody has access to anything without explicit permission. Now, how do we configure these? Many people try to implement this design using IP tables. IP tables is the legacy and deprecated network firewall stack. And currently the active network firewall stack in Linux is NF tables. NF tables is included, like WireGuard, it is included in almost every kernel that is being built. I decided to use NF tables here. You will see the output that NF tables gives us. It is a really beautiful output and very easy to understand. So we will write NF tables that will bring up the WireGuard interface and configure routing on the WireGuard interface so that whenever any one of these clients connects, we will redirect them, or we will forward their packets to the appropriate service. If the tester wants to access a service that is not one of the assigned services for it, the packets will drop. This is how we model the information that we have seen in the diagram. So we have first the IP addresses of the server, of the WireGuard server, which is 10.10.10.1 and 10.10.15.1. I'm using two class C subnets for each one of the groups. The DNS server is the default DNS server for the router. And then I have two services. I have the WG service test and the WG admin. WG stands for WireGuard. And I used this namespace to distinguish them from other firewall rules that we will create later on the Devlab router. In each service that I design, we have chains of firewall rules. And in this service, for example, we have the access rule that defines destinations, this IP address and these hosts, this IP address and these hosts, and this IP address, which is the DNS server, and UDP on UDP port and on UDP and port 53, which is the DNS access. So basically, what I am saying, if I send any packet to this chain, what will happen if the destination is this IP on these ports, or this IP on these ports, or this IP on protocol UDP and these ports, here protocol is TCP. So if the destination matches these, I will pass the connection. This is the rule that will be generated for WireGuard. And you see here, we are not playing with NF table. These are just definition of services. We are defining the services, and the Ansible, the role, will do all the complicated stuff of generating the NF tables rules. This is the second rule, and here we see that we want to access on board TCP and UDP the entire Devlab network on both protocols, TCP and UDP, on all ports. Then we define our peers, and here I try to use the WireGuard's default syntax. So we have the IP of the peer. So we have the first IP that would be 10.10.10.10 that would use this public keys, and the allowed IPs are in this context here are the IPs that WireGuard will send packets to. So WireGuard will route packets to this host only if the destination is this destination, which is the host itself. I do not want my hosts to contact each other. The table is WG admin, which is this table, and the chain WG admin access, which is this chain. We have a similar setup for the test machine 10.10.15.3. And we have a public key and the IP and the service. Using Ansible, the result of using this, I will show you how I got the result, but the result would be something like this. So this is running on the router itself. Now we are on the router itself. This is the configuration file that was generated for WireGuard. We have address and listen port private key. This is the private key for this WireGuard, which is inside, and I will change it later. Then we have the DNS server, the DNS definition. Then we see that we are using WG Quick, which is a tool for configuring WireGuard, and this tool allows us to set up hooks. And there are 4 hooks: the pre up, then the post up, and the pre down, and the post down. Now this was entirely generated from these configurations. You don't worry about that, and the role will generate it all. The algorithm here is pretty simple. Before we create the WireGuard connection in pre up, we create the rules that are specific to the destination. So let's look at the generated rules on the server here. If I type nft list rule set and expand this, let's expand this entirely. We see that we have some rules regarding like built in the firewall. Then we have the WGNAT rule, which is similar to this rule here, to our routing rule that we created earlier. Like it's almost identical, but the routing here is between WG0, the WireGuard interface, and the network interface, the internal network interface, that is ETH100. we have a table that includes this chain and the main chain. In this chain, we have everything related to the output. And we can do that in pre-up. We can load that in pre-up because it's the services are there. And we don't need to depend on the interface. Now, this here depends on the WireGuard interface. So we need to do it in post-up so that we have the WireGuard interface up and running. And that is a challenge normally in configuring WireGuard, how to secure the WireGuard connection and interface. So for example, here I have one client that will use it. So I have one rule that says if the input interface is this interface, which is WireGuard, and the input IP address is this IP address, which we got it from the variable file. We count the packets, and right now we have 172 packets with these bytes, and we jump to the WG service test access, which is this chain here, and we run through this chain. So here we have the input interface, the input section of the firewall rule, and here we have all the output sections of the firewall rule. And we have the same here in this table. All this was generated on two steps. The first step is we created the configuration, and that configuration generated this firewall, this WireGuard file. And the second step is when we started WireGuard, these commands were executed, and the result was these firewall rules. So now let's see the template that generated all this configuration here and here from this variable file. The template is here. It might look overwhelming, but it is very easy to understand. These are loops inside loops. First, we start generating the interface part following the WireGuard quick WG quick file format. So these are keywords that we have to use. Then we start using the hooks. So first we create the NAT table, and then we start building the other table that we have seen. So this is a table, this is a for loop on the table, then a for loop on the chains in the table, and then a for loop on the destinations in the chain of the table. And this corresponds to what we have seen in here. So we have a for loop for the table, then a for loop for the chains. We have here one chain, and then a for loop for the rules, and the rules are done. Here we have another for loop to clean up before we close down WireGuard, and here we loop on the peers, and we generate the rules for the peers. And then in the end, we define the peers. So we have multiple peer sections that define our peers. Now, this is the task file, and the task file is very simple. We install WireGuard packages, which are the WireGuard package and the resolve-conf, which is needed to configure DNS, and the nftables package that we need to configure to run NFT. Then we copy the template to its appropriate place, and we install the WireGuard service. That's all. With this role, the Devlab router allows restricted access from the outside, but it allows also unrestricted access from the inside to the outside, which means that the Devlab hosts can access any host on the main network, which might be a security risk, and we need to solve that. The most serious issue is that our router is open to the main network. That is okay for now because we are assuming that that we are all inside the main network. So nobody from the internet has a route to access our router. However, a main router misconfiguration or a misplaced Ethernet cable can expose the Devlab router to the outside world without any protection, and that also needs to be fixed. I have been using a similar setup for about 2 years. I think it is good enough for a Devlab. My main DMZ server runs similar Ansible generated code, and I have friends connecting to some of my services remotely. So as far as I know, This setup works and it is as secure as possible, but we need to fix the issues above. I have to say that I am not a network expert. Although I have learned a lot in my lab, I would really like a real network expert to look at the rules and advise me and possibly advise us all. Please feel free to comment your opinion or to send a code review or a pull request to the repository. I have enjoyed working on the Devlab router a lot, and especially the ideas I came up with Ansible. Previously, I was using a Python script that was very difficult to maintain, especially when I want to change the rules for some reason. Now with this YAML file, it is very easy and I can regenerate the entire configuration whenever I want. We have one problem here is that our bind role has a bug. The bug is when you rerun the role, the bind server fails because I forgot to commit the records that bind has in journaling. So whenever I reboot the server, the zone loses sync with the journaling or the cached records that are not committed. So I modified the role for that. And there are other few modifications that I will commit along with the pull request of this episode. I would like also to highlight this thread that I had with Imtiaz Ali. He's saying, hi, I just tried today with Alma Linux and but it was not successful. While troubleshooting, I add a line to gitlab.rb and this is the line and reconfigure GitLab and it worked. So apparently the install was successful, but he was having troubles when reconfiguring GitLab, and we had a small discussion here. And finally, I asked him to send me a pull request to the repo. And I'm grateful for Imtiaz Ali for sharing his ideas and for sharing his experience. And I look forward to the pull request. Next, I want to focus more on the Linux router. I am enjoying the work on the Linux router and the work on the AI content more than I enjoyed working on the development environments. Season 2 is still pending. My intention is to build something on OKD and start a big series to use OKD, which is the community distribution of Kubernetes, and basically it's supported by Red Hat, as Ansible is supported by Red Hat, as Fedora is supported by Red Hat. So I'm thinking of using OKD. In multiple professional projects before, I have used OpenShift, and I think I am an expert in that, but we will see what I can do with OKD. If you have other ideas or if you want me to investigate other ideas regarding season 2, please let me know. I would like to thank all the people who follow me on YouTube, GitHub, Medium, and the other platforms, and especially the people who leave me comments. Those interactions with the audience give me the feeling that my videos provide some value to some people. If you think my videos or my code provide any value to you, please let me know in the best way for you. As usual, the code will be in my GitHub repository when you see the video. And the link to the repo will be always below this video and in the article that is also linked below this video. There will always be a pull request in the repository on GitHub. And the code I wrote for this episode will not be merged until a pull request for the next episode is published. Maybe you will enjoy looking at the code and telling me what you think. I welcome comments, code reviews, and other types of feedback on the code in GitHub and on the other platforms. Please feel free to fork the repository and modify it to match your own Devlab. You might be interested in the previous episodes of the Devlab series where we built DNS and DHCP and dynamic DNS on the Devlab router. If you like AI art, please check my AI playlist. You will find a competition between large language models, and how I designed my stable diffusion workflow from scratch, in addition to the recent experiments, which include designing tattoos using AI and designing a social media influencer using AI. Please follow my work and let's meet in a previous episode or in a next episode.